So in today's class, we will be discussing about the applications of embedded systems. Okay, first we will take up application-specific embedded system like a washing machine, and then we will discuss about domain-specific examples of embedded system. Okay, so moving on, uh, embedded systems are both application-specific and domain specific. So you should know what is the meaning of application specific and domain specific. Okay. Before going into the meaning of application and domain specific, you should know that uh, embedded systems are specifically built for certain applications. Okay. So say washing machine is designed for a purpose like washing of clothes, and it belongs to consumer electronics washing machine. So it is also domain specific and also application specific because it does washing of clothes. Your smartphone, okay, is an example of consumer electronics. So it is also domain specific, and it has many applications like making calls, browsing internet, transferring music file to a laptop or some other friend's phone, etc. And automotive, industrial control. These are all other domains where embedded system can be used. So they can be used particularly in consumer electronics and telecom. They can also be used in automotive and industrial applications. Okay. Uh, Coming to the washing machine. Okay. So washing machine is an example of a home automation type application of embedded system. So home automation, everything inside the home is automatic. So you can automatically wash the clothes. Okay. So this embedded system consists of so many things like sensors, actuators, control unit, and other user interfaces like keyboards, displays, etc. Okay. So you can see all these components in the washing machine if you have a closer look at it. Okay. So if you look at it closely, okay, you can have a view of all this. Okay. But some of them are inside the washing machine, so they may not be visible to you. So some are visible, some are not visible. Okay. So we will see now what and all things are there in the washing machine. One is the sensor part. So you may have a water temperature sensor or level sensor. Okay, so many sensors you may have. You may have a actuator. Actuator is something that does action. Okay, like motorized agitator for mixing the uh, washing powder and water with the clothes. So tumble tub for holding the water and the clothes, and water drying pump for drying the water, and inlet valve to control the flow of water. Okay, these are all actuators. That means they do certain actions depending upon the input from the sensor. Okay. Then you have the control part. Okay. Control part is that which controls the sensors and the actuators. So sensor senses the signal and it is sent to the controller part. Controller tells actuator to perform certain actions. Okay. So that is about control part. So this control unit consists of many user interfaces like keyboard for setting the washing time, for selecting the type of material to be washed, like light clothes, heavy clothes, medium clothes, like that. So control unit is a user interface for the user to specify certain instructions like washing of the clothes, type of washing, time of washing, all those things can be specified. And finally, how does the user get the feedback of the washing that is happening in the washing machine? Through display units and LEDs. Okay, so user gets the information. Okay, so this is a typical diagram of a block diagram or the internal diagram of a washing machine. So here you can see many sensors are present in the washing machine, like your
Hello, sir.
hello. Yeah.
Sir, Pooja want to join the class, sir,
Okay. Okay.
but
I'll
it is
allow.
not possible, it seems.
Yeah. I'll allow. Yeah. Yeah.
Okay, sir.
Okay. So the washing machine has got a temperature sensor. Okay. So many sensors, water level sensor. These are two examples. You can see here. Okay. Temperature sensor and level sensor, water level sensor. These are two sensors that are present. Then apart from that, there are actuators like water outlet, inner tub, outer tub, water inlet pipe, etc. These are all actuators, and there are these controllers. So microprocessor is there, microcontroller is there. Okay, and there are certain display units like LED display and so on. Okay, and there are keypads for giving the inputs. Control instructions can be given through the keypad. Okay, so these are the examples. Okay. So these are the description of the various interfaces that are present in the uh, uh, washing machine. So control panel consists of microcontroller with I/O interface and control algorithm for controlling the operation of washing machine. Okay. Then you have input interface like you have a keypad which will help you to wash, spin and rinse the clothes. So you can wash light, medium, heavy, or you can set the time of washing. Okay, all these things are possible. Output interface, so it gives certain indications to the user like through LED displays, LCD displays, status LEDs, etc. These are connected to the input output bus of the controller. Okay, they give an indication whether the washing is complete or what is the status of the washing. All this indication can be given by the output interface. Okay, this interface may vary from manufacturer to manufacturer and model to model. Okay, the output interface depends on the model and also it depends on the manufacturer who manufactures the washing machine. Okay, so other types of IO interfaces are invisible to the user. Maybe it might be somewhere inside the washing machine, like temperature sensor, water level sensor, and there may also be actuator interface like motor control for agitator, tub movement control, inlet valve control, etc. These are all actuators. They help in performing certain action like motor control for agitator. So motor runs means tub will rotate. So agitator will mix the clothes and uh, water with the powder. Okay. And tub movement control. So how it has to rotate with what speed, all these things. And inlet water control. So inlet water control is how much of water should flow, whether half tub, full tub, or little bit. Okay. So this was all about washing machine application specific embedded system. Now we will move on to the domain specific examples of embedded systems. Okay. So various domains are there in embedded system like consumer electronics, automotive, telecom. Okay. Of these three, telecom and automotive industries are very popular and they have a large market share. Okay. So they are very popular. So now we will see the internal working of automotive embedded systems or automatic embedded systems. Okay. Uh, so what is this automotive embedded system? So when electrons take control of the mechanical systems, it is called automotive embedded systems. So the hardware part is mechanical, but the other controlling part is the electronics. Okay. So there are various embedded system components that are present in the embedded system. Okay, like simple mirror, wiper controls, or there may be complex components like airbag controller, anti-lock braking systems in the automotive embedded system. Okay, so usually these automotive embedded systems are built around microcontrollers or DSPs. Okay, DSP means digital signal processor, or they may be a mixture of both. Okay, so you can have a microcontroller, or you might have a mixture of both. Okay, so you have the electronic control unit. Okay, so these are called electronic control unit. So DSPs or microcontroller, which is a control unit. It is because based on electronics, it is called electronic control unit. Okay, so these are all examples of components present in automotive embedded systems. Okay, now moving on to the different types of control units that are present in automotive embedded systems. One is a high speed and another one is a low speed embedded control unit or electronic control unit. Okay, what is this high speed electronic control unit? Okay, this high speed electronic control units are used in time critical conditions like you cannot have much delay or slowness. Okay, it should have fast response. So like fuel injection systems, anti-lock braking systems, etc. Okay, these are the examples of high speed electronic control units. Low speed electronic control units. Low speed electronic control units are used in applications where response time is not critical. Okay, response time is not important and is not so critical. So those are the applications of low speed electronic control units. Okay, so difference is that these electronic control units are low cost. They are based on microcontrollers with low cost, and they also use DSPs. They are also of low cost or smaller DSPs. Examples. Okay, we can have audio controllers, passenger and driver door locks, door glass control, etc. These are all examples of LECU, that is low speed electronic control unit. Okay. Next, moving on to the automotive communication buses. Automotive means automobile. Communication buses are buses used for communication inside the automobiles. Okay. Three types are very popular in automotive industry. One is the CAN, controller area network. Another one is the LIN, local interconnect network. And another one is MOST, media oriented system transport. Okay, these are all important communication interfaces or buses. So we will have a brief overview of all the three. Okay, so CAN, what is this CAN? CAN is a event driven serial protocol. Okay, event driven. Event means some event is happening, means the CAN will be activated. So event driven serial protocol interface with support for error handling in data transmission. Suppose if there is some error in data transmission, so CAN plays an important role. Okay, where it is used? It is used in airbag control and powertrain systems like engine control and anti-lock braking systems. There it is used. CAN. And then LIN. Okay, single master multiple slave. Okay, bus. So it is also used in communication interface. LIN is a low speed single wire communication interface with support for data rates up to 20 kbps and is used for sensor actuator interfacing Okay, media oriented system transport. Okay, the last one is targeted for audio and video equipment interfacing. So most bus is a media fiber optic point-to-point communication network. Okay, most. It's a fiber optic network used for audio and video interfacing. So the topology used for most bus is star topology or ring or daisy chain topology for fiber optic cables. Okay, this star, ring, daisy chain topologies are all topologies for uh, fiber optic cables. Okay, that is all about today's class. So tomorrow we will meet with a new topic. So if anybody is having any doubts, you can ask. Anybody is having any doubts? So we have completed today's class. Okay, so if anybody is having any doubts, okay, anybody is having any doubts? I'm not able to get any response from you. No. Okay. Anyway, so we'll meet tomorrow at 10 o'clock. Okay. Uh, Same time.